Are you trying to find a data center for your disaster recovery site? You might want to think about going to Texas. Talk about why.
Welcome to Tech Topics brought to you by Cybervenger. We help keep small businesses stay protected and compliant with cutting-edge cybersecurity and IT solutions.
Okay, so Texas. Why Texas to build your data center? Well, first thing, you have to understand that power, electricity, is one of the #1 reasons why a computer system or network would be unavailable. It's honestly the top threat to network availability, even more so than viruses and ransomware and that sort of thing. Uninterruptible power supplies, or UPSs as they call them, very common piece of equipment. Every server has one because power is a very easy to see and understand threat, and it's a very common one. I mean, you're most likely to have a UPS in your server room than you are to have even redundant hard drives or redundant power supply or a cluster or any other high availability stuff, because power is the big thing. Now, unbeknownst to many people, America has actually divided the power grid, that is, into 3 sections. You've got the eastern, you've got the western, and then you got Texas. Texas is its own power grid. Now, that made the news a while back. During a winter a couple of years ago, it got cold, much colder than Texas is used to dealing with, and some of the transmission lines got frozen and stuff went down. And there are other reasons involved that had nothing to do with weather. And people were complaining that Texas was not attached to the rest of the national power grid. Okay, what does it mean by attached? So, a power grid is a very complex system of involving power generators, transmission lines, transformers, redundancy, and monitoring, control systems, and of course consumers. To understand how all this works and why this is important, you need to understand a couple basic components about electricity. Electricity coming out of your wall is something called AC current. And what that means is that the polarity of your electricity is going from negative positive to positive negative and back and forth. And does this 60 times per second, or 60 cycles. That's the standard for modern electricity. Not every power grid is necessarily 60 cycles. You could hypothetically build something in another country of some other, rate. But 60 cycles is the stock standard here in the U.S. And interestingly enough, Quebec is part of the East and West, or Canada is part of the East and West. Quebec is also, like Texas, its own grid. So maybe you can get a data center in Quebec too. But so go back to the cycles, though. That is part of the nature of the AC current. You can't get 2 AC providers connected to the same grid if they're operating at different speeds. Similarly, they have to be synced up. You could have a scenario where you have 2 power generators and one is kicking in right when the other is dropping off, or the polarity is fighting. It's got to be consistent. It's got to be controlled. So you have that. You also have the type of power. So you've got voltage. Most of us know voltage. Right? A home outlet is 110, right? Thereabouts, sometimes 120. It can vary wildly, actually, and still be within spec. And that's voltage. And then there's another thing called amperage, also known as current. Now, electricity, the total amount of power that you have available to you is generally measured in watts or kilowatts. That's a term that tends to be used for the consumption side. Okay, we burned 5 kilowatts hours today, or maybe 100 kilowatt hours this month, or that's how much electricity your business, your company, organization is using. What happens when you're transmitting power? So you got your power company that makes the power. By the time you transfer it to homes far away from the power company, you generally have a degradation of voltage. Electricity runs into resistance over the wires. Now, AC, and one of the reasons they use AC, is much more resistant to resistance. Yes, that sounds silly, but AC works better over long distances than DC does, the other kind of electricity. But voltage does still go down after many miles. And what can end up happening is you have voltage at 110 and it sags down to 100 or 90 or something. That's not enough to run modern equipment. Equipment is generally very sensitive to voltage. It needs to have the specific correct voltage, not too low, not too high. Now, amperage, on the other hand, as long as you have enough, you're fine. Like money. It's okay to have extra money. It's not okay to not have enough, but you got to have, extra amperage is fine in this scenario. So what they'll do is they will rob Peter to pay Paul. They'll burn up some amperage to get more voltage back. This happens in what's called a transformer, those power distribution centers, those big giant boxes with all the wires sticking out of them. You see sometimes the huge transformers that will take all that electricity and add some voltage back in at the cost of a little bit of amperage. Wattage stays the same. Well, actually, wattage, you lose a little of that too over because of resistance. But the point of all this, I know this is a very long, complicated explanation. Trust me, it gets way more longer and complicated than that. I'm not a power expert. I just know the basics. There's plenty of YouTube videos out there that go into details of how the power grid works. But you get a taste of how complex this will all be. It has to be controlled. In the old days, it was done kind of manually. It was done through more mechanical systems, and it wasn't as good. We had more power outages. When I was a kid, a power outage was not as rare as it is today. At least it doesn't seem like it was. And a lot of that is thanks to modern computer-controlled infrastructure. So these power grids, so the Eastern being one, and the Western being the other, Texas being a third, each have their own IT network, if you will, that is tracking the power distribution center, the transmission lines, the consumers consuming electricity, the power plants making electricity, the wind turbines, the solar, the nuclear, the coal, the natural gas. All that's constantly being fed, and it's a ton of information to keep track of. All the electrical inputs have to be aligned to the same frequency and all that. Way more complicated than I exactly understand or am explaining correctly. Again, this is the dummies version, not exactly correct. But you get the idea. This is all controlled by software, increasingly more and more. And the software is connected remotely. Maybe some of you are seeing where I'm going with this. A lot of it is even connected indirectly or directly to the internet. This last year, according to a Reuters article I was reading, they're reporting that cyber attacks against power companies have increased by 70% this last year. Now, nothing really happened power-wise this year that was big news, although last year the Keystone pipeline got attacked, so we had a successful breach of the natural gas side of our energy infrastructure. Electricity, they're trying, and any number of adversaries the U.S. would love to tap into our power grid and take it down. What does that mean for you? Well, if you're building disaster recovery, you probably want to make sure that your disaster recovery data center is not attached to the same power grid as your primary data center. That way, at least your customers can get to your website and run your business. If you're, especially for a global company. Now, if you're a small mom and pop and need electricity to produce your product, you're probably screwed anyway. Maybe that's a little more advanced than you need to bother thinking. But if you are a company that could survive a local interruption, maybe you got a remote office, maybe you're a manufacturing company, got 2 manufacturing plants. If your IT goes down, everything goes down. But if just perhaps power only affects one plant, at least you can continue to make your other products. There's something to think about. And you may want to put your disaster recovery in a different grid. Put it in Texas, or if you're an Eastern, put it in Western, or vice versa. There's nothing specifically great about Texas. It's more that it's its own isolated grid. Kind of get the idea. That way, if the grid is taken down due to a software cyber attack, odds are that one of the other 3 grids will continue to run because they're not directly connected, do not directly affect each other. So that's just something to think about. Again, I don't want to get too much into power distribution as I'm not really an expert. I just know the basics, and I know from a disaster recovery and planning standpoint, it's nice to stagger things so that one domino does not knock over the next domino. Keep your dominoes away from each other. That's a good motto for disaster recovery planning. And that's all I got on that subject today. I hope you found it helpful, and I hope to see you in the next video.
Thanks for watching. We hope this video has provided valuable information to you. Be sure to share this video with other small business owners to spread the word about the importance of cybersecurity. As always, don't forget to like and subscribe for more videos like this. If you want more information about cybersecurity, visit us at www.cybervenger.com.